Welcome back everyone. Today I am going to start that class 9th mathematics quadrilateral chapter exercise 8.2. The first question of exercise 8.2 is saying to you ABCD is a quadrilateral in which PQRS are midpoints of sides AB, BC, CD and DA. AC is diagonal so that SR is parallel to AC and SR is half of AC. Second is saying PQ is equals to SR and PQRS is a parallelogram. So before going to solve this problem, I want to make you understand the midpoint theorem because it is going to be applied in this problem. So according to midpoint theorem, if we have a triangle A, B and C and D and E are the midpoints of AB and AC respectively, then line joining this midpoint will be parallel to BC and half of that BC. How can you prove it? First of all, we will draw a construction here. Draw a parallel line to AB and will extend this DE. So if and suppose it is intersecting at point F. Okay, so what will you do? Construction, what will you draw? CF parallel to AB. Now in triangle AED, this triangle and triangle CEF, this angle 1 will be equals to angle 2, angle 1 will be equals to angle 2 from vertically opposite angle. Since these two lines are parallel and transversal is AC, so this angle will be equals to your this angle. Means angle you can say DAE is equals to F angle FCE alternate angle. And AE is equals to EC since E is the midpoint of AC. So our triangle AED will be congruent to triangle CEF from angle side angle. So what can you write? You can write DE is equals to EF. Your DE will be equals to your EF and AD will be equals to your CF. So if I suppose this is equation number 1, this is equation number 2. Now what can we say? This AD is coming equals to CF. So AD is also equals to your DB. Since D is the midpoint of AB, D is the midpoint of AB. This is equation number 3, you can say. From equation 2 and equation 3, this AD are equal, so you can say CF is equals to your EF. CF, no, sorry. CF is equals to DB. CF is equals to DB. AD are left hand side are equal, so CF will be equals to your DB. From construction, CF is parallel to DB also. So since CF is equals to DB and parallel to DB, hence DB FC is a parallelogram. Okay, so if it is a parallelogram, so our DF will be equals to your DF will be parallel to BC. Hence, it is a parallelogram. This has become parallelogram. So DF will be parallel to BC. DF will be parallel to BC. Or you can say, in place of DF, you can say DE is parallel to BC. Or you can also say DE is parallel to BC. Say for suppose it is equation number 4. This DE will be also parallel to BC. Now, since DF is parallel to BC and DF CB is a parallelogram, hence DF will be also equals to BC. It will be parallel and equal also. DF will be parallel and DF, how can you write? DE plus EF. You can write DE plus EF is equals to BC, and from equation number 1, DE is equals to EF. So in place of EF you can write DE, so DE plus DE will become equals to BC. From question number 1, so from here you will get D will become half of BC. So it is your midpoint theorem. Okay, equation 4, it is your equation number 5. So from equation 4 and equation 5, we are getting that line joining the midpoints of two sides, which is D, is equal to half of the third side, and this D and they are parallel to each other. Also, it was the midpoint theorem. Please recall it. So this midpoint theorem we are going to use in this problem first of exercise 8.2. So what is in this problem? What is given to us? First we'll write to given. We have a quadrilateral ABCD. P, Q, R and S are the midpoints of AB, BC, CD and DA. AC is diagonal of ABCD. So this all information is given to us. We have a quadrilateral ABCD. A, B, C and D. PQRS are the midpoints, and it is given to prove. In to prove, first point, second point and third point we want to prove, which is all written here. Okay. We'll join PQRS and AC is a diagonal. Okay, now we'll prove it. In triangle ACD, if you look, ACD, this triangle, S is the midpoint of AD and R is the midpoint of CD. So from midpoint theorem, your SR will be parallel to AC. Line joining the two midpoints will be parallel to the third side. This triangle you are selecting, so this will be parallel to this, and with this SR will be also half of AC. So first point has got proved. Similarly, in triangle ABC, P and Q are the midpoints of AB and BC respectively. Hence, this PQ, line joining this midpoints, PQ will be parallel to AC and PQ will be half of AC. From midpoint theorem. So AC, if it is, this is equation number 1, this is equation number 2, this is equation number 3, this is equation number 4. So from equation 1 and equation 3, what can you write? SR will be parallel to PQ. AC right hand side are equal, so right side, so SR will be parallel to PQ. And from equation 2 and equation 4, this SR, half of AC are equal, so SR will be also equals to PQ. So you are finding SR is equal and parallel, and here this is equation cats, this is dogs. From equation cats and dogs, what can you write? PQRS is a parallelogram. As proved. Okay, so we have proved in a quadrilateral the line joining the midpoints will be a parallelogram. We have also proved that SR will be parallel and half of AC, and PQ is equals to SR. That also we have proved here in Dock's equation. Now come to the second problem. Okay. Question is saying to us that ABCD is a rhombus and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. So that quadrilateral PQRS is a rectangle. So a rhombus is given to us. Okay. And this is our A, B, C and D. Once again this P, Q, R and S are the midpoints joining, so that the quadrilateral joining PQRS is a rectangle. In a rhombus, if we are joining the midpoints of the sides, so it will form a rectangle. We want to prove it. So what is given to us? Given we have a rhombus AB, CD, PQ, R and S are the midpoints of AB, BC, CD and DA respectively. To prove, we want to prove PQRS is a rectangle. Want to prove, we'll do a construction here. First we will prove it a parallelogram. Join AC. So we'll join this AC. Okay. Now the same thing. First we will prove it a parallelogram. So in triangle ABC, PQ will be parallel to AC and PQ will be half of that AC. So equation number 1, equation number 2. This is all from midpoint theorem. And in triangle ADC, SR will be parallel to AC and SR will be half of AC. This is equation 3. This is equation 4, and it is from midpoint theorem. From equation 1 and equation 3 and equation 2 and equation 4, what we can say, PQ will be parallel to SR. This AC are equal, so PQ will be parallel to SR, and PQ will be also equals to SR, and hence PQRS is a parallelogram. First we will prove it a parallelogram. So we have proved it from midpoint theorem. Now ABCD is a rhombus. So AB will be equals to BC. AB will be equals to your BC. If you are multiplying half both sides, so no change will take place. So half of AB, what can you write? Half of AB, you can write as your PB. Better to write PB. PB, and half of BC, what can you write? BQ. PB will be equals to your BQ, and when this PB is equals to your BQ, so equal sides will subtend equal angles in triangle PBQ. So angle 3 will be equals to your angle 4. It is, you can write equal sides subtend equal angles. Okay, now what will you do? You will select these two triangles, this triangle and this triangle. So in triangle APS and triangle CQR, now these two triangles, and it is a rhombus, so what can you write? AB is equals to your BC. AB is equals to your BC. Half of AB is equals to half of BC. AB is equals to BC. Why? They are rhombus, so they will be equals. So half of AB, what can you write? Half of AB you can write as your AP. AP, and half of BC you can write as your CQ. So AP is equals to CQ in these two triangle. AS is equals to say is in the same way. Also AD is equals to CD. Also AC is equals to CD. Half of AC will become half of CD. Half AD, I'm sorry, AD, half of AD is equals to CD. So what can you write? Half of AD is equals to half of AD. AS is equals to half of CD is equals to RC. CR, two sides you have made equal, and PS is equals to QR. PS is equals to QR, and PS is equals to QR. How can you write? Parallel sides of parallelogram PQRS. We have proved that PQRS is a parallelogram. So this is A, B and C. So from A, B and C, what can you write? Triangle APS is congruent to triangle CQR. This APS will be congruent to CQR. Hence, angle 1 will be equals to angle 2. This you can write angle 1. This you can write angle 2. Hence angle 1 will be equals to your angle 2. Hence angle 1 will be equals to your angle 2 by CP CT. What will you do? You will consider this is as a straight line. Means now angle 1 plus angle SPQ plus angle SPQ plus angle 3. Angle 1 plus angle 3 plus angle SPQ must be equals to your 180 degree. Consider it as a cats. In the same way, angle 2 plus angle 4 plus RQP or PQR. Similarly, angle 2 plus angle PQR plus angle 4 is equals to 180. It will be rats. Okay, from cats and rats, what can you write? Angle 1 plus angle SPQ plus angle 3 will be equals to angle 2 plus angle PQR plus angle 4. Angle 1 is equals to your angle 2. Okay, angle 1 is equals to angle 2. And angle 3 is equals to angle 4 we have already proved. And angle 3 is equals to angle 4. So angle SPQ will be equals to angle PQR. So these two angles will become equals to each other. And this we have proved. Since SP is parallel to QR. SP. This SP is parallel to QR. It is a rhombus. So this parallel. So these two angles transversal is intersecting and they are parallel to each other. So this angle plus this angle must be equals to your 180. So angle SPQ plus RQP. Angle SPQ plus angle PQR. Angle PQR must be equals to your 180. This acts as a dots. Okay, so 2 times of angle SPQ will become 180 from dots. Okay, you can put they are equals to it. So angle SPQ will come out 90 degree and implies that angle PQR is equals to 90 degree. So they are coming equals to, this angle is also of 90 degree, this angle is also of 90 degree, and it is a parallelogram, so opposite sides will be equals to 90, 90, 90. Hence PQRS is a parallelogram whose angles are of 90 degree. Hence it is a rectangle. Now come to the third problem. It's just the reverse of that second problem, I think. ABCD is a rectangle and PQRS are the midpoints of side AB, BC, CD and DA respectively, so that the quadrilateral PQRS is a rhombus. Earlier in a rhombus you had to prove that rectangle. Now in a rectangle you have to prove a rhombus. So same midpoint, from the same midpoint theorem we will first prove it as a parallelogram. Then after we will proceed. So we have a rectangle, okay, A, B, C, D. So what is given to us? Two given rectangle A, B, C, D, and P, Q, R and S are the midpoints of sides A, B, B, C, C, A, C, D, C, D and D, A. So this P, Q, R and S are the midpoints of these sides A, B, B, C, C, D and D, A. Okay. And to prove, what do you want to prove? PQRS is a rhombus. This we want to prove. And construction. We'll do a construction. Join AC. What will you do? You will join AC. Okay. Now proof. What will you do? In triangle ABC, PQ will be parallel to AC and PQ will be half of AC. Midpoint theorem. And in triangle ACD, S and R the midpoints, so line joining the midpoints of two sides will be parallel to the third side, means AC, and SR will be, and half of that the third side, half of AC. This is midpoint theorem. AC right hand side, so question 1, 2, 3 and 4, from 1 and 3 PQ will be parallel to SR, from second and fourth PQ will be equals to SR, so they are parallel and equal, PQ, and hence PQRS is a parallelogram. First we will prove it. So we have proved it as a parallelogram, means opposite sides are equal. If somehow we are capable of proving that adjacent sides are equal, so it will become a rhombus. Now in rectangle ABCD, AD is equals to BC, opposite sides. If we are multiplying by half both sides, no change will take place. And half of AD you can write as your AS. Half of BC you can write as your BQ, because S and Q are the midpoints of these two sides. Make it as equation number CATS. Now in triangle APS, and in triangle BPQ, what can you write? AP is equals to your BP. P is the midpoint of AB. Angle PAS angle PAS will be equals to your PBQ. Each of that equals to 90 degree. It is a rectangle, so they will form same angle 90 degree. And AS is equals to your BQ from CATS. So what can you write? Triangle APS is congruent to triangle BPQ. So you have made them congruent. Implies that PS will be equals to your PQ. PS will be equals to your PQ by CPCT. And if it is a rat, and if it is a mat, so rat is saying that means ki PS is equals to PQ, adjacent sides are equal, and parallelogram is saying to you opposite sides are also equal. So adjacent sides are equal and opposite sides are equal, hence PQRS is a rhombus. We have proved it. Come to the next question, fourth question I think. ABCD is a trapezium in which ABCD is a trapezium in which AB is parallel to CD, BD is a diagonal, and E is the midpoint of AD. E is the midpoint. A line is drawn through E parallel to AB, intersecting BC at F, so that F is the midpoint of BC. So that the F is the midpoint of BC. So first, what is given to us? ABCD is a trapezium in which AB is parallel to DC, BD is a diagonal, and E is the midpoint of AD. A line is drawn through E parallel to AB, intersecting BC at F is also given to us. Want to prove? To prove F is the midpoint. F is the midpoint of BC. We want to prove it. So we'll prove it. Let DB, this DB which is a diagonal, intersect EF at G. Let it is intersecting at point G here. Then we'll select this triangle in triangle ABD. In triangle ABD, E is the midpoint. E is the midpoint of AD and EG parallel to AB. Since EF is parallel to AB, it is given to us. So if EF is parallel to AB, so EG will be also parallel to AB. So E is the midpoint of this and this EG is parallel to this. So this G point should be also a midpoint from the converse of midpoint theorem. From the converse of midpoint theorem, midpoint theorem was that if the if the midpoints, the line joining the midpoints of two sides will be parallel and half of the third side. So here, since they are parallel and E is the midpoint, so G should be also midpoint by converse of midpoint theorem. So therefore G is the midpoint of DB. And in bracket you will write by converse of midpoint theorem. Now we will consider this triangle BCD. So again, in triangle BDC, is BDC, okay, G is the, we have proved that G is the midpoint of DB. G is the midpoint of BD and this GF, this EF is parallel to AB, so GF will be parallel to AB and this AB will be parallel to CD as ABCD is a trapezium. So this GF will be parallel to AB and AB will be parallel to CD. So and this GF is parallel to AB is parallel to CD. Since EF parallel to AB is given to us. Therefore, if G is the midpoint of that CBD, G is the midpoint of BD and this GF is parallel to CD, so F will be also the midpoint of BC by the converse of midpoint theorem. Midpoint theorem का उल्टा है तो ये F भी क्या होगा, इसका midpoint होगा. Therefore F is the midpoint of BC, bracket you can write by converse of midpoint theorem. Come to the next question. In a parallelogram ABCD, E and F are the midpoints of side AB and CD. E and F are the midpoints of sides AB and CD respectively. See figure. So that the line segment AF and EC trisect the diagonal BD. This we want to prove here. So according to question, E and F are the midpoints of sides AB and CD respectively. So what can you write? You can write AE is as the half of AB and CF is the half of CD. But this ABCD is a parallelogram, not this, but ABCD is a parallelogram. So AB will be equals to CD and AB will be parallel to CD also. What can you write? Half multiplied by half, both sides. And AB is parallel to CD. Half of AB is equals to half of CD. Meaning is that half of AB is AE is equals to half of CD is CF and AB parallel to CD. So AB parallel to CD and AE is equals to CF, AE is equals to CF. Okay. AE is equals to CF. So they are parallel. So AE will be also parallel to FC. So AEAFC will become a parallelogram. Okay. This equation number 1. It means AECF. AE will be parallel and these are equal, we have proved. Okay. So AECF will be is a parallelogram. We have proved it. First we will prove it parallelogram. So this AF will be equals to AF will be parallel to CE, and when AF will be parallel to this, AF will be parallel to CE, so you can write FP is parallel to CQ. Means FP is parallel to CQ. You can write because FP is the FP is the part of FA and CQ is also part of CE. Okay, this is equation number 2. You can write. Here is the equation number 1, equation number 2. Now, in triangle DCQ, this triangle DCQ, F is the midpoint of CD. F is the mid point of CD and FP is parallel to CQ. FP is parallel to CQ and FP is parallel to CQ from equation number 2. From equation number 2. Hence, these are parallel and F is the midpoint of this, then P will be also the midpoint of DQ by the converse of midpoint theorem. Hence, P is the midpoint of DQ by converse of midpoint theorem. Okay. So P is the midpoint of DQ, means DP will be equals to PQ. That is, DP will be equals to your PQ. Make it as equation number CATS. Okay. Similarly, in triangle B, BAP, this F this side, E this side, no, BAP, I was looking that side, I'm so sorry. So in triangle BAP is the midpoint of AB, E is midpoint of AB, and this EQ is parallel to AP. EQ, they are parallel to each other. AF is parallel to CE, so this EQ will be also parallel to AP. Okay, so directly I am writing EQ is parallel to AP. EQ is parallel to AP. Here you can write, since AF is parallel to ECE, it is equation number 2. AF is parallel to CE. EQ will be also the part of this. So they will be parallel and E is the midpoint of this. So this Q will be the midpoint of what? Q will be midpoint of BP. And if Q is the midpoint, so PQ will be equals to QB. That is, PQ is equals to QB. Make it as equation number RATS. So from these two equations, from CATS and RATS, DP will be equals to PQ will be equals to QB. Make it as equation number MATS. Okay. Now BD, this BD you can write as a DP plus PQ plus QB. So BD you can write as your DP plus PQ plus QB, and they are equals to each other. So BD will be equals to 3 times of DP. This is, you can say, from maths. Okay, so DP will be equals to 1 by 3 of BD. This equation you can say bats. So from mats and bats, dP is equals to your PQ is equals to your QB is 1 by 3 of BD. Hence proved. Now come to the one problem. So that the line joining the midpoints of opposite sides of a quadrilateral bisect each other. Very good problem. So that the line joining the midpoints of opposite sides. Okay. So line joining the midpoints of opposite sides means this line joining the midpoints of opposite sides of a quadrilateral bisect each other. So you will draw a figure. ABCD is a quadrilateral in which PQRS is the midpoint. So the line joining the midpoints of opposite sides. Line joining the midpoints of opposite sides bisect each other. So what will we do? We will join PQRS and we'll prove it is as a parallelogram by the help of midpoint theorem. Excuse me. And once it will proved parallelogram, so diagonals of parallelogram bisect each other. It is a property. So we'll do it. First we'll join AC. Join AC. Join AC and now consider the triangles. In triangle A D C, S is the midpoint of AD and R is the midpoint of CD. So by midpoint theorem, SR will be parallel to AC and SR will be half of AC by midpoint theorem. Okay, make it is question number 1, question number 2. And in triangle now ABC, P is the midpoint of AB and Q is the midpoint of BC. So from midpoint theorem, this PQ, line joining the midpoints of two sides, will be parallel to the third side and half of that. PQ will be parallel to parallel to AC and PQ will be half of AC. Make it equation number 3, equation number 4. From equation 1 and 3 and equation 2 and 4, this ACC SR will be parallel to PQ and SR will be equals to PQ. SR will be parallel to PQ and SR will be equals to PQ. Hence, PQRS is a parallelogram. We have proved it as a parallelogram. Now this PR and QS. Now PR and SQ are the diagonals of parallelogram PQRS and diagonals of parallelogram bisect each other. Therefore, this if they are intersecting at point O, so PO will be equals to OR, PO will be equals to your OR, and SO will be equals to your OQ. Okay, so they will bisect to each other. Other problems given in this exercise 8.2 is your homework. Okay, solve all these problem 5 times.